about problems related to exercise 1, and also the difference between similar figures and congruent figures. Now in this class we are going to learn one of the important theorem that is known as basic proportionality theorem or Thiel's theorem. Okay, and exercise 2, now all the problems are related based on the theorem. Okay, for the statement, open page number 32 in your part 1 textbook. So the heading is basic proportionality theorem. Basic proportionality theorem. Okay, so this theorem comes for 5 marks. So in your question paper pattern, the last question carries 5 marks. In that they will ask one theorem, either Thiel's theorem or basic proportionality theorem, or they will ask the Pythagoras theorem. Okay, so this theorem is also known as Thiel's theorem. Okay, the basic proportionality theorem is also known as Thiel's theorem. These are the two names for this theorem. And in page number 32, they give the statement theorem 2.1. Well, that is the statement of basic proportionality theorem. So according to the statement, if a line is, so I will write the statement, you just refer your textbook. If a line is drawn, parallel to one side of a triangle, parallel to one side of a triangle, to intersect the other two sides in distinct point, other two sides in distinct point. The other two sides are divided in the same ratio. So this is the statement. So according to the statement, or basic proportionality theorem states that, so if they ask us to prove the sides ratios are equal, then first we have to write the statement. Okay, that is according to basic proportionality theorem, or according to Thiel's theorem, or Thiel's theorem states that, and in that you have to write this statement in double inverted comma. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point. Okay, that means we have to draw one line which is parallel to one side of the triangle in two distinct points. It intersects the other two sides in distinct points. The other two sides are in the same ratio. The other two sides are divided in the same ratio. Now to prove this, I will just draw one small figure. So I will consider one triangle. This is the base of the triangle. I will call the end points as A, B, C. That means vertex. Okay, ABC is one triangle according to the statement, if a line is drawn parallel to one side of the triangle, so I will consider BC as the one side of the triangle, then I will draw one line which is parallel to this side. Okay, I will draw one line here, and I will name the endpoints as D and E. So now, according to the statement, I have drawn one line that is parallel to one side of the triangle. So therefore, here DE is parallel to BC. Okay, the distance between the are parallel to each other. The next, intersect other two sides in two distinct points. So the two distinct points are D and E. Now for the side AB, the point is D, and for the side AC, the point is E. Then the other two sides divided in the same ratio. Other two sides, that means side AB and side AC are divided in the same ratio. That means we have to prove AD divided by DB is equals to AE divided by EC. What we have to prove is, we have to prove AD divided by DB, that is equals to AE divided by EC. That one we have to prove. First I will write the given data. This is very important theorem. Okay, listen carefully. Given ABC is a triangle. First one, ABC is a triangle, and then the next point given is DE is parallel to BC. Okay, DE is parallel. This is a parallel symbol. DE is parallel to BC, and D intersect AB, and DE intersects AB. DE intersect AB at point D. At D, and line AC at E, and AC at E. So this is the given vectors. Okay, we draw in that one line is parallel to other side of the triangle, and we mark two intersected point on line AB and AC. Now what we have to prove? To prove what we have to prove, it is given that the other two sides are divided in the same ratio. Other two sides are divided in the same ratio. That's why I have to write AD divided by DB, that is equals to AE divided by AC. Okay, so here AD divided by DB, that is equals to AE divided by EC. Now to prove that, we have to do small construction. Okay, I'll write the next part. Up now, how many of you understood? Just comment your name first. Basic proportionality theorem, that is also called as Thiel's theorem, and this is a statement. The statement is, if a line is drawn parallel to one side of the triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. They will not give the definition. You have to memorize the definition. Okay, and for that I consider one triangle, and according to the theorem statement, I have drawn one line D which is parallel to BC, and the line D intersect the line AB at point D, and the line AC at point E. Now according to the statement, what we have to prove is, we have to prove AD divided by DB, that is equals to AE divided by AC. That means the other two sides are divided in the same ratio. That one we have to prove. Now for that we have to consider we have to do the construction. So next part, construction. Join point B to E and C to D. Okay, join point B to E and C to D. So I will join the line with the help of dotted line. Okay, so this is the line which joins point B and D, and I'll draw another line which joins the point D and C, or C and D. The next one, draw DN perpendicular to AB. Draw DM perpendicular to AE, and so for that I will draw one perpendicular line. So perpendicular means it gives 90 degree, and another line, this also perpendicular. Okay, we have to draw perpendicular line. So I will call this point as M and this point as N. So here in the construction I have to write, draw DM perpendicular to AC and EN perpendicular to AB. Okay, DM perpendicular to AC. So perpendicular to AC means that is perpendicular to AE also. Then EN perpendicular to AB, that means EN is perpendicular to AD also. This is the construction, small construction. Now next I will directly go to the proof. Okay, so proof. Now I will consider the triangles. Okay, first I will consider the left hand side triangle, that is triangle ADE and triangle BDE or BED. Okay, these are the two triangles here. Now I will consider this triangle and this triangle. Consider triangle ADE. Consider triangle ADE and triangle BDE. Okay, so I consider two triangles. Now I will take the ratios of the two triangles. Okay, I will take the ratios of the two triangles. So it becomes area, ratios of the area. Okay, area of triangle ADE divided by area of triangle BDE. So these are the ratio. Now area of triangle ADE. Okay, ADE. So this is one triangle. Now in this, the perpendicular height is EN, that means EN is perpendicular to AD. So by considering the formula, half into base into height. So now remember one thing, in the first part consider left hand side. Okay, so AD as the base. Okay, remember for the first half consider AD as the base, because AE also base, because DN is perpendicular. We can consider that also, but we will consider that in the next part. So first part consider base AD in the numerator and base BD in the denominator. Consider only left hand side. Okay, so therefore I will consider half into base is AD into height is EN. That is the area of triangle ADE. Next, divided by area of triangle BDE. So this is not an equilateral triangle, or this is not a right angle triangle. This is obtuse angle triangle, because here this angle is greater than 90 degree. Okay, that angle is greater than 90 degree. So in that case, to find out the area of the obtuse angle triangle, we have one special formula, that is, for example, if this is the triangle, so A B C, then what we have to do is we have to draw one perpendicular line. Okay, so that is half into base into height. So if I consider this as AM, then this is the height of the triangle. Similarly here, half into base is BD, and height. So from this point, this is one obtuse angle triangle. From this point, I consider one right triangle, one perpendicular line, that is EN. So that one we have to consider. Okay, see here. So from the upper point, we have to draw one perpendicular line, and we have to consider that line as the height of the triangle. Okay, this is extra part. Okay, no need to draw this. Therefore, I will consider half into base. Base is BD. So I told you that consider right left hand side, or BD, or I will consider directly DB. Okay, because here we consider DB, that's why here also I will consider DB. Into height is EN. Now EN gets cancelled, half gets cancelled, only remaining. Therefore area of triangle ADE divided by area of triangle BDE, that is equals to AD divided by DB. I will call this as equation number 1, AD divided by DB. So this is the remaining one. Now similarly, we have to consider the other part also. Similarly, this is similarly symbol. Similarly, consider triangle ADE and triangle DEC. See here, the triangle is again ADE and DEC. Now in the previous one we consider DBE. So in that case we consider left hand side. Here also left hand side as the base. Now I am considering DEC. Therefore we have to consider right hand side part as the base. So for the lower triangle we have to consider EC as the base, and for the upper triangle we have to consider AE as the base. Okay, so therefore this theorem becomes this part, area of triangle ADE divided by area of triangle DEC, that is equals to half into base. Base is now right hand side AE, and height is DM. Half into AE into DM. Just refer your textbook or notebook for the diagram. Okay, so AE into DM. AE into DM divided by, next for the lower triangle again half into DEC, half into base is EC or CE, but here we consider EC, therefore I will consider EC, and height, this again obtuse angle triangle, this is the upper point. From this I have to draw one perpendicular line, and that we have to consider as the height of this triangle. So that is height is here DM. So therefore half into EC into DM. Again DM gets cancelled, half gets cancelled. That's why remaining is area of triangle ADE divided by area of triangle DEC equals to AE divided by EC. I will call this as equation number 2. Okay, just follow these two parts and comment me how many of you understood this. Comment your answers fast. Comment your names fast. How many of you understood this? Very important theorem, and click on the like button. Okay, if you understood this, then I will go to the next part fast. You see here the numerator part triangle ADE, and here also triangle ADE. So that means numerator part is same. Now we have to consider the denominator part. So denominator part is area of triangle BDE and area of triangle DEC. See here, area of triangle BDE, so this triangle, and area of triangle DEC, this triangle. See here, both are present on same base, that is D, and both are present between same two parallel lines. So DE and BC, that is parallel line, that is given in the statement, and therefore these two triangles present on the same base, that is DE, and present between the same two parallel lines, that is DE and BC. And in 9th standard, we in parallelogram chapter, we studied that if two figures are present on the same base and present between the two parallel lines, then area of their two figures are equals to each other. Or if you consider triangle, if two triangles are present on the same base and they are present between the same two parallel lines, then area of the two triangles are equals to each other. Okay, therefore equation 1 and equation 2, the left hand side of equation 1 and left hand side of the equation 2 are equals to each other. So that's why I'll write the statement. But triangle BDE and triangle DEC are present on the same base, DE, and present between two parallel lines DE and BC. Therefore area of triangle ADE is equals to area of triangle DEC. Area of triangle, it is BDE, that is equals to area of triangle DEC. So therefore, by comparing equation 1 and equation 2, so both left hand side are equal. So therefore according to axiom, we learned in 8th as well as in 9th standard, we learned about axioms. So axioms are the statements or assumption which are true for all branch of science and mathematics. So according to that, if two things are equals to same thing, then that two things are equals to each other. If two things are equals to same thing, then that two things are equals to each other. So that means equation 1 is equals to certain area and equation 2 is equals to certain area, and we know that two areas are equal. So therefore the initial statement, that is right hand side, also equal. So therefore AD divided by DB, that is equals to AE divided by AC. Hence proved. Okay, this is the this is the theorem. We just refer the next step and comment me how many of you understood this. Comment your name first. Based on that, we have to solve the theorem. We have to solve the problems. Then open exercise 2.2. Exercise 2.2. Just open page number 36. So solve the problems along with me, then we will get the exact idea to solve the problems. So in figure 2.17, 1 and 2, in both the case D is parallel to BC, find EC in 1 and AD in problem number 2. For that I'll draw a small figure. First one. This is a figure, and the vertices as A, B, C, then D and E, and the sides are given length. This is 1.5 centimeter and this is 3 centimeter. This is a rough figure, okay, so that the values are not exact. So now we have to find out EC in this. So what is given? In the triangle ABC, D is parallel to BC, that is given. In triangle ABC, DE is parallel to BC. D is parallel to BC. Then according to basic proportionality theorem or Thiel's theorem, if a line drawn which is parallel to one side of the triangle and it intersects the other two sides at different points, then the ratios of the other two sides are equals to each other. So just now proved that. So here AD divided by DB, that is equals to AE divided by EC. So I'll write AD divided by DB, that is equals to AE divided by EC. Now we have to substitute the values. AD value how much? 1.5 centimeter and DB value 3 centimeter, that is equals to AE value 1 centimeter and EC value unknown. We have to add that value as it is. Now simple cross multiplication. So it becomes 1.5 into EC, that is equals to 3 into 1. So therefore EC value becomes 3. 3 into 1, 3 divided by 1.5, and we know that 3 divided by 1.5, that gives 2. 1.5 1 is 1.5 2 is, therefore EC value is 2 centimeter. How many of you understood this? Just comment your name first. And similarly we have to solve the second one. I'll draw the diagram. A, B, C, and one line which is parallel to BC. The endpoints are D and E. The lengths are given 1.8 centimeter and EC value 5.4 centimeter and BD value 7.2 centimeter and AD is unknown. We have to find out AD value. Okay, again here it is given that D is parallel to BC. Again we have to apply Thiel's theorem. So here small reason we have tried by Thiel's theorem. Okay, by Thiel's theorem. So we have to add the reasons also. So now for this problem, First I will write in triangle ABC, DE is parallel to BC. DE is parallel to BC. Then according to Thiel's theorem, or you can write according to basic proportionality theorem. Okay, you can write any one word. So what is here? AD divided by DB, that is equals to AE divided by EC. AD divided by DB, that is equals to AE divided by EC. So now we have to substitute the values. AD value how much? It is unknown, divided by DB value 7.2 centimeter, that is equals to AE value 1.8 centimeter and EC value 5.4 centimeter. Okay. Next, cross multiplication. So therefore AD equals to 1.8 into 7.2 goes to numerator, divided by 5.4. Okay, now solve this and comment me the answer fast. 18 ones are 18 threes are 54. So decimal point we can neglect. So it becomes 3. Then 3 ones are 3 twos are 6. Point it becomes 12. Then 3 fours are 12. So answer is 2.4 centimeter. 2.4 centimeter. How many of you understood this? So try to solve fast. Okay. Then the next one. Second mean. So in front of second question they gave one figure 2.18, but that is not the relevant figure for the second question. So that figure 2.18 is the figure for question number 3. Okay. So I will consider the next one, second mean. So in second mean it is given that E and E are points on the sides of PQ and PR respectively of a triangle PQR. That means first I will draw one triangle PQR. PQR, and E and F are points on the side PQ. PQ. This is E and this point is F. In the of a triangle PQR, for each of the following case state whether EF is parallel to QR. We have to prove EF. We have to find out whether EF is parallel to QR or not. So that gives the corollary of the inverse of the Thiel's theorem. So according to Thiel's theorem, if a line parallel to one side of the triangle, then the other two sides are divided in the same ratio. Now we have to use, if two sides are divided in the same ratio, then the one side is parallel to the given line. So that one we have to do. So that gives the inverse of the Thiel's theorem. So for that we will consider the triangle PQR. Consider triangle PQR. Consider triangle PQR. Now we have to find out the ratios. The values are given. For the first one, PE is how much? It is 3.9 centimeter, and EQ is given, that is 3 centimeter, and PF is given as 3.6 centimeter, and FR is given as 2.4 centimeter. Just we have to find out the ratios. If they are equal, then we have to write EF is parallel to QR. If the ratios are not equal, then EF is not parallel to QR, we have to write. Okay. First I will consider PE divided by EQ. Let consider PE divided by EQ. PE value is how much? 3.9 centimeter divided by EQ value is 3, and the total value becomes 3 ones are 0.3, 1.3. So centimeter gets cancelled, therefore ratio does not have any SI units. Then similarly we have to consider the next side ratio. So consider PF divided by FR. PF value is 3.6 centimeter and FR value is 2.4 centimeter, and by cancelling this, so 6 4s are 24, 6 6s are 36. Okay, decimal point we can neglect. Then 2 2s are 2 3s are, so therefore ratios come 3 by 2, and it is equals to 1.5. So the first one is 1.3 and the second one is 1.5. So therefore 1.3 is not equals to 1.5. So therefore we can write, therefore PE divided by EQ, that is the first one, that is not equals to PF divided by FR. Therefore EF is not parallel to QR, not parallel to QR. Okay, if the ratios are equal, then they are parallel. If here in this case the ratio is not equal, so therefore the lines are not parallel to each other. Then similarly second one I will solve now. Again we have to consider one triangle PQR. PQR, and one side, one line, the points are D and E. Sorry, E and F is given, E and F, and the lengths are given. P equals to 4 centimeter and EQ equals to 4.5 centimeter, and PF equals to 8 centimeter and RF equals to 9 centimeter. Now again we have to find out the ratio. In triangle PQR, PE divided by EQ. Okay, PE divided by EQ, one side ratio. PE value is 4 divided by EQ value is 4.5 centimeter. So when we remove the decimal point, so when we took this front, so here 1 0 comes, it becomes 40 divided by 45. 5 8s are 40, 5 9s are 45, it becomes 8 divided by 9. Then similarly if I consider PF divided by FR, PF value is 8 and FR value 9. So directly we got the value. So therefore here PE divided by EQ is equals to PF divided by FR, because PE divided by EQ, that is equals to 8 by 9. Similarly PF divided by FR, that is equals to 8 by 9. So therefore the first ratio is equals to second ratio. So therefore EF is parallel to QR. Converse of Thiel's theorem. Okay, this is the method to solve the problem. Just look at the answer. So just try to solve the third sub question. Okay, if the ratios are equal, then the given line EF is parallel to QR. If the ratios are not equal, then the given line EF is not parallel to QR. The next one. So third problem. In third problem, in figure 2.18, first I will draw the figure. This is the diagram, and point A, B, C, D, and for the line CD we have to draw one parallel line, and similarly for line BC we have to draw one parallel line here. So the intersected point is L and the end points as given as M and N. So in the figure 2.18, LM is parallel to BC and LN is parallel to CD. Prove that AM divided by AB, that is equals to AN divided by AD. Okay, this is known as corollary of Thiel's theorem. Okay, if one line is parallel to other line, then the other two sides are divided in the same ratio, that is Thiel's theorem. If two sides are in the same ratio, then the two lines, drawn line is parallel to another side of the triangle, then that is converse or reverse. Okay, we are not using reverse, we are using converse of Thiel's theorem. And if see here, if LM is parallel to BC, then AM divided by MB, that is equals to AL divided by LC, that is Thiel's theorem. And corollary of Thiel's theorem states that if LM is parallel to BC, then AM, listen carefully, then AM divided by AB. Okay, this AM divided by AB, that is equals to AL divided by AC. Okay, that is called as corollary of Thiel's theorem. Now we have to prove the theorem. So we will consider the triangle ABC. This third one. Consider triangle ABC. So in ABC, LM is parallel to BC. LM is parallel to BC. Now according to corollary of Thiel's theorem, okay, according to corollary of Thiel's theorem, AM divided by AB, that is equals to AL divided by AC. We will call this as equation number 1. AM divided by AB, that is equals to AL divided by AC. Now similarly, we will consider the lower triangle, that is triangle ADC. In triangle ADC, LN is parallel to CD. LN is parallel to CD. Then again we will apply the corollary of Thiel's theorem. According to corollary of Thiel's theorem, AN divided by AD, that is equals to AL divided by AC. AL divided by AC. So we'll call this as equation number 2. In the first one, AM divided by AB, that is equals to AL divided by AC. In the second triangle, AN divided by AD, that is equals to AL divided by AC. So now when we compare the equation 1 and 2, the right hand side are equals to each other, therefore according to axiom the left hand side also equal. Compare equation 1 and 2. So it gives AM divided by AB, that is equals to AN divided by AD. Hence prove. Hence prove. How many of you understood this? Just comment your name. Just comment your name first. So in this class we learned about Thiel's theorem, or also that is known as basic proportionality theorem, and converse of Thiel's theorem, and next one is corollary of Thiel's theorem. Okay, corollary of Thiel's theorem. And the theorem is very important theorem. It carries 5 marks, and it is most probable question, most probable question. Okay, thank you everyone. I will continue in the next class.